Hey there, fellow electricity enthusiasts. It's Abdul from Eedemy, and today we're diving into Ohm's Law, the magical rule that keeps your gadgets from exploding most of the time. If you've ever wondered why your phone charges at the speed of a snail when using a cheap charger, this is for you. And don't worry, I won't throw boring equations at you. Okay, maybe just a few, but I promise to make them painless. Fun fact, Georg Ohm, the genius behind Ohm's Law, probably never imagined his name would be used to explain why your toaster refuses to work. But here we are. What is Ohm's Law? Ohm's Law is the golden rule of electricity, describing how voltage, V, current, I, and resistance, R, work together. It was discovered by the German physicist Georg Ohm, who spent years experimenting with circuits, probably getting electrocuted more times than he'd like to admit. The higher the current, the bigger the zap. Real-life example. Ever tried using a knockoff phone charger and wondered why your phone stays at 1% forever? That's because low voltage plus high resistance equals frustration. It's like trying to drink a milkshake through a coffee stirrer, just not happening. The mathematical formula of Ohm's Law. Here's the holy trinity of Ohm's Law equations. 1. Voltage equals current multiplied by resistance. 2. Current equals voltage divided by resistance. 3. Resistance equals voltage divided by current. If math makes your brain hurt, don't worry, just remember the Ohm's triangle memory trick. Imagine voltage, V, as a grumpy boss sitting on top, and current, I, plus resistance, R, as two stressed employees below. Cover the one you need to find, and the equation magically appears. Ohm's triangle, a simple way to remember, just arrange V, I, and R in a triangle like this. V, voltage, goes on top. Why do we use I instead of C for current? Good question. Turns out the French scientist André-Marie Ampère called it intensité du courant, meaning current intensity, so we use I instead of C. Imagine trying to measure current and accidentally setting your oven to 1000 amps instead of 1000 degrees Celsius. Yikes, on fire. Practical examples of Ohm's Law. Example 1, finding voltage, V. Imagine you're building a top-secret DIY laser gun. Just kidding, FBI. You know the resistance is 5 ohms and the current is 3 amperes. How do you find the voltage? Using Ohm's triangle, voltage equals current multiplied by resistance. In this case, voltage equals 3 multiplied by 5, which gives 15 volts. Boom! Your circuit has 15 volts. Just don't point that thing at your neighbor's cat. Hee. You have a light bulb with a resistance of 6 ohms connected to a 12-volt battery. How much current is flowing? Using Ohm's triangle, current equals voltage divided by resistance. In this case, 12 volts divided by 6 ohms equals 2 amperes. That's 2 amps, enough to keep your room lit up, but not enough to power your PlayStation. Sorry, gamers. Example 3, finding resistance. Say you have a mini electric heater connected to a 24-volt power source and it draws 4 amps of current. What's the resistance using Ohm's triangle? Resistance equals voltage divided by current. In this case, 24 volts divided by 4 amperes equals 6 ohms. Great. Now you know why your heater takes forever to warm up. It's all about resistance. On fire. Test your knowledge of Ohm's Law. Let's see if you're an Ohm's Law master. Try these. 1. A gaming PC power supply outputs 750 watts at 125 volts. What's the current? Drop your answers in the comments. I promise I won't judge much. And that's Ohm's Law in a nutshell. Hopefully now you understand why your charger is slow, your light bulbs burn out, and why electricity is both awesome and terrifying. If you laughed even once, you owe me a like and a subscribe. Catch you in the next video.